Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Sumiamira binti Mofazi and my metric number is BTU1112. Okay, the given task was food battery. I choose food battery. Batteries are a device that stores chemical energy and convert to electricity. This is how batteries power electronics and electrical equipment such as cell phones, MP3 players, watches, and so on. Based on the kind of electrolyte used, there are two types of batteries. One of it is wet cell, which uses the liquid electrolytes in the form of solution, and the other one is a dry cell, which uses electrolyte in the form of a paste. Are two different types of cell. So zinc cell, alkaline cell, nickel, cadmium cell, Edison cell, and mercury cell are just few numerous varieties of the battery accessible today. So, in this project, we will create our own battery out of fruit and vegetables with enough power to light a little 3-volt bulb. Because some fruit will contain a citric acid, a fruit battery will work. This acid is involved in a chemical process that causes electrons to flow, resulting the creation of electricity. These fruit batteries, on the other hand, have a very low voltage, probably under 1 volt. The electrical current in most fruit is eligible amperage. So, the term voltage refers to the amount when a current of 1 ampere travels to a resistance of 1 ohm. A potential of 1 volt arises across that resistance. In addition, a flow of electrical charge carries generally electron or electron deficient atom is referred to as a current. The capital letter I is a typical sign for a current and ampere. The ampere abbreviated as A in the standard unit. So the term current and voltage we can know as P equals to IV. So the quantity charge of Q transferred through the voltage in a time period T is the energy utilized. It is the same as the power integral over time. So the kilowatt hour or 1000 watt operating over 1 hour is a typical measure of a describing energy use. So the material that we use is fruit and vegetables. So in my experiment, I use apple, orange, potato, and cucumber. And we also use a zinc galvanized nail that is 2 inches long, a copper strip. I use it coin as the copper strip, connecting wire, knife to cut the fruit and vegetable, a multimeter to measure voltage and current, alligator clips, and LED light. That's 3 volt. So for the first procedure, we have to roll the fruit at the tables to lose the juice in the fruit. Then make a slit so you can put the galvanized nail in it, and do the same step for the penny. Leave a bit outside so you can connect it to the alligator clips like this. Make sure to put it in series, and the galvanized nail and the penny has to be opposite, because the fairer the electrode, the higher the voltage it will produce. To measure the current, you have to put the multimeter in series. For voltage, you have to put it in parallel with the circuit. So here is how the connection The positive probe will go to the penny and the negative will go to the galvanized nail. So we got 2.552 volt. So this is the result that we got. For the apple, we got 0.8 voltage, and the current ampere we got the 0.02 milliampere. So refer to the power formula. We know that P equals to current times voltage. So 0.02 milli times 0.8 equals to 16 micro. For the apple, we got the power is 16 microwatt. So follows for the orange, 14.8 micro, followed by the potato, that is 87 microwatt. The cucumber, 22 microwatt. So we tried this one result is for the one fruit only. For this one shows that the result for 1 until 5 fruit that we use to make fruit battery, like the previous result that we got for 1 fruit, followed by 2 fruits, 3 fruits, 4 fruits, and 5 fruits. We can see that the power increases if the fruit increases. For the discussion, citrus fruit are acidic, and the more acidic they are, the better conducting electricity they are. So therefore, the fruit battery operated despite the fact that the nails are not touching each other. Ions with positive charge can be found in the fruit. The negative charge ion or electron started to travel from the fruit to zinc nail when you place the galvanized or a zinc nail to the fruit, leaving the proton in the fruit. As soon as the wire connected to the nail, electricity is generated. The bulb illuminates. If I were to generate any system that could generate 20 watt of electricity, I need more than 3.6 thousand fruit or vegetable to provide the required amount of power. Battery can never be truly useful, as the experiment demonstrated. The idea was incorrect since there's no link between fruit's pH and amount of energy it generates. So the equivalence of the findings, that is, pH has no bearings on the amount of energy generated. So for the conclusion, based on the experiment I have done, I will agree that fruit are more acidic, have higher voltage and amperage. Sweet, ripe ones, on the other hand, are less effective. We also discovered if the electrodes were too close together, they would not create much amperage. Based on some experimental testing we conducted without recording the result, we were unable to obtain conclusive result when the testing many fruit at the same time due to indicate equipment. When we started testing numerous fruit at the same time, we ran across a difficulty. We had to adapt our approaches by substituting alligators clipped with a small wire according to the condition. They are not practically powerful and they take up a lot of room individually. The fruit that produce maximum amperage are more expensive than the stored bulb battery. So to me, the battery that we have right now is better than fruit and vegetable. So fruit batteries are not portable, and even the smallest energy consuming device will require a lot of fruit to power it. In the nutshell, the experiment was a success. That's only from me. Thank you.